Assalamualaikum and good afternoon, guys. So today we are going to pick up what we left last week on multi-agent system. Okay, last week we have learned the basics of multi-agent system, one of the methods available in artificial intelligence. So this week we are going to look into detail on how to use a multi-agent system, especially in order to solve manufacturing related problems. Okay, as for the starts, multi-agent system is the enabler, one of the enabler for us to establish a distributed control system. So basically, what is this distributed control system? Let's have a look and compare between two of the available control system. So in order to establish any system within manufacturing plant, so we need to decide on what system that we are going to deploy. The first option that we have is the centralized version, that is the picture on the left hand side. So by using centralized control system, we connected all of the entities within the system to one central controller. So by doing so, that single controller will be used to give order to the entire entities within the system. On the other hand, we have a distributed control system, that is the figure on our right. So in a distributed control system, we equip all of the entities within the system with the capability to receive information, process information, and also making decision on its own, and then communicate with the other entities within the system what has been decided. So this is a newer version of a control system that is increasingly becoming more popular nowadays, especially with the establishment of IoT, Internet of Things. Okay, let's have a look on the differences between a centralized and distributed system. So in a centralized system, the entities that consist within are normally non-autonomous component. What is the meaning of non-autonomous? It means that the components or the entities do not have capability to make their own decision. Everything must come from the top control. So it is a top-down system. And also for centralized system, often built using homogeneous technology, meaning that we must select one single technology in order to build the entire system. And the third one is multiple users shares the resources of a centralized system at all times. So by doing so, more often than not, we will have some difficulties. The system might have some difficulties in order to cater with all the needs, especially when we are dealing with dynamic changes. And the last one is that the main weakness for centralized system is that it has a single point of control and of failure. So anything happen to the centralized controller, any failure to the centralized controller, it may jam the entire system. So on the other hand, by using distributed systems, we have autonomous components, normally multiple autonomous components, and distributed system may be built by using heterogeneous technologies. So meaning that, for example, if in a certain workplace we already have several different technologies, we may be able to connect those technologies and make sure that those technologies interact with each other. The third attribute of a distributed system, it may be used exclusively and are executed in concurrent process, meaning that at one time we have the capabilities to make multiple decision making simultaneously. And the last one, for distributed system, we have multiple points of failure. So meaning that if we have a failure at a certain point, we may have backups, and the failure and one failure may not easily disrupt the entire system. Okay, let's have a look on one example of using a robot in a warehouse.
On the ranking of things to worry about, Skynet coming and taking over doesn't even rank in the top 10. It distracts attention from the more urgent things, like, for example, what's going to happen to jobs.
For a glimpse into the future, consider one of the largest companies on the planet, Amazon.
Amazon has tremendous scale. We have fulfillment centers that are as large as 1.25 million square feet. That's like 23 football fields. And in it, we'll have just millions of products.
To deal with that scale, Amazon has built an army of robots.
Like a marching army of ants that can constantly change its goals based on the situation at hand, right? So our robotics are very adaptive and reactive in order to extend human capability to allow for more efficiencies within our own buildings.
And there's plenty more where those came from. Every day, this facility in Boston graduates a new batch of machines.
All of the robots that you see that are moving the pods have been built right here in Boston. I call it the nursery, where the robots are born. They'll be built. They'll take their first breath of air. They'll do their own diagnostic. Once they're good, then they'll line up for robot graduation, and then they will swing their tassels to the appropriate side, drive themselves right onto a pallet, and go directly to a fulfillment center.
To some of us, this moment belies a dark sign of what's to come, a future that doesn't need us, one where all jobs, not just cab drivers and truckers, are taken by machines. But Amazon's chief roboticist doesn't see it that way.
The fact is really plain and simple. The more robots we add to our fulfillment centers, the more jobs we're creating. The robots do not build themselves. Humans design them, humans build them, humans deploy them, humans support them, and then humans, most importantly, interact with the robots. When you look at that, this enables growth, and growth does enable jobs.
Certainly, history would seem to bear him out. Since the Industrial Revolution, new technologies, while displacing some jobs, have created new ones. While this is the predominant view in the AI community, some think it ignores the reality of today's world.
There's a long history of technology creators assuming that only good things would happen with their baby when it went out into the world. Even if there are some new jobs created somewhere, the vast majority of people are not easily going to be able to shift into them. That truck driver who loses their job to a driverless truck isn't going to easily become an app developer out in Silicon Valley.
Okay guys, so what we have just watched is a group of robots that moves around materials within a warehouse, within the Amazon warehouse. So basically what is done by the robots is actually within the scope of what we call AGV, Automated Guided Vehicle System. Okay, I'm going to explain on how to deploy multi-agent system in order to increase the efficiency of AGV system in the next slide.